Cool. Welcome everyone to another 100 Days of No Code workshop. Really excited to be here with you all, of course. Today is an exciting session with Mark. He's going to be talking all about APIs, that dreaded, scary topic, at least it is for me. But hopefully he's going to shine some light on what the heck they actually are and how you can kind of improve and sort of power up your no-code projects using this technology. So I think we're going to just run through what APIs are, some jargon, and then how you can use them to level up your projects. And then we will get into some questions at the end. Hopefully that sounds good to you guys. And I shall now pass it over to you, Mark, to take it away.
Thank you very much. It's good to be. I'll just share my screen and we can. Can you see that okay? Is that all right?
Perfect.
Grand. Yeah, thank you very much. Thanks for everybody for turning up. Thanks for Max for giving me the opportunity to talk about APIs. We're just going to have a run through what I've learned, and hopefully I can share that with you in a sensible way. My name's Mark. I'm a member of the 100 Days of No Code community, and I've found it an awesome help in becoming a builder. So if you've not completed the challenge already or Max's course, then I'd encourage you to do that, and we can carry on developing this community together. I completed my 100 days of challenge, 100 days of no code challenge over a year ago, and I'm still here. So it's going pretty well. But just bear in mind that I'm not an API expert. So I'm a no-code builder just like you. So I'm here sharing what I've learned so that you can better understand what the tools we're using are doing behind the scenes, and hopefully broaden your skill set. So today we're just going to have a look at a few items here on the list, what APIs are and how they work. I've got some examples that we can step through, hopefully you can relate to, and then we've got some time for some questions hopefully at the end of it. And yeah, I've got a list of links as well for the stuff we're going to look at. So if you don't catch quite where we're at, don't worry, there's some info at the end that you can take away with you. Please feel free to stop me anytime and ask a question. I'd like this just to be informal, and I'd rather you stop me so we can examine the topic more if you don't quite get it. But if I don't know the answer, then I will do my best to find it out and get something to you after the workshop. So without haste, let's move on. What are APIs? Humans are excellent at handling information, and it's something that's been built in us. So if you're proposed a question along the lines of what is your age, or a similar question of how old are you, they're two different questions, but as a human, you're likely to be able to come up with the right answer. Computers, however, they need some explicit rules in order to conclude a correct answer. They're not very good at having some intuition in terms of what the question's intent is in the first place, whereas humans handle that quite well. So those rules are where the API comes in. Now, APIs, in my mind, are the rules that enable computers to talk with each other. That is what we need to bear in mind. So that's why I'm being a bit emphatic about what that is. Part of that is the communication, and what communication requires is interfaces. We have interfaces for humans, and they're the user interfaces that we sort of use every day with our apps and our software. So computers have an interface as well, and that's the application programming interface, or the API. So they're both interfaces, but so that's how they communicate with each other. But obviously one is for humans and one is for computers. So this is a typical line of communication for software. If we go from left to right, hopefully everybody knows what a human is. So we'll skip that and go on to what a client is. That's the word in API talk that people use for a browser or an application, and it's on any device and a client is used for requesting data. The next item is the server. So that's another computer, but it's purely for receiving those requests and handling the requests and then issuing a response. It can also get data from a database, and there's lots of other uses for it, but these are the sort of things you see when you see pictures of Google's big data centers. They're all servers. They're not like your typical computer with screens and keyboards and mice. They're just purely for processing the data on bulk and very efficiently. The user interface that we talked about for the human is on the client. That is where we interact, and that's on the client side, and the application program interface, or the API, is on the server side. So that's where these two interfaces live. A human will use the user interface on the client, and then the client will communicate with the server using the API. And that's the sort of broad strokes of what we're talking about here. If we drill down into the relationship between the client and the server, again, I've already explained that they're both computers. I mean, you can sort of interchange the word software and computer as far as the client goes, because a browser is a client, an application is a client. So if I use them interchangeably, they do mean the same thing essentially. When we're on our client computer or software, and we push a button or we fill out a form, some information is sent over to a server. Now, this is the various items that we're talking about with the communication. So you can be saying, please, can I have some data? Or please, can I add some data? Or please, can I delete some data? And this is our request. That's the term that we use when we're moving information from our client to a server. When the server receives that, it handles whatever the request is, and then it sends information back to the client. Now, this is called a stateless communication. So it's not recorded anywhere. It's a transaction that happens and then ends. So it doesn't, that particular transaction isn't a persistent thing. That's not particularly relevant, but it's just something to bear in mind. When the server responds back to the client, it will give you some information about what it's done, and it will say, yes, here's the information, or it will say no, but it will give you a reason why you can't have the information. That is our response data. So just to recap, the client is your browser or your app, and this sort of situation allows many clients to talk to one server, which is perfect for massive scale across the globe, where many users contact one particular server or one particular API, and it can be handled quite easily. On the server side, that is where the API lives, in the data center there, and along with the database that can live on the server, or the server can access that. And that's what we're talking about with the communication things. Now let's have a little look at the rules that we were referring to when we mentioned them about what the API is. So the headline rule to bear in mind when we're talking about the APIs that we're going to be typically exposed to is that they are called REST APIs, and that stands for representational state transfer. It sounds really cool. I don't really know what it means, but if you have understanding that the REST APIs are the architectural style of an API, so there's different architectural styles that you're looking around and finding the built environment, you can relate that as an analogy for APIs, in that the REST APIs is an architectural style of building an API, and each API is a building in the style of the REST architecture. So there are various types. We're only interested in the REST APIs because that's what we're going to be exposed to in our no-code building. So just bear that in mind. You don't need to know any more than that. But if you're working on building something and you come across these terms, you'll be aware of it, that you want to be looking at REST APIs. So the rules that are included in an API are typically referring to the restrictions and limitations that are placed on what happens to the data and who can access it. And there's multiple categories. I've picked the sort of popular ones here. So the resource is the actual data that we're talking about. It's the images or the products or the users or the videos that are stored in the database and that people can access through the API. They're called resources. And we'll drill down into all this stuff in a little bit more. We'll just briefly go through the typical rules. Security is obviously quite significant. So the API provider can know who is accessing the API by giving them explicit secure access. So depending on the data and who they want to access it, you may not have any security if it's a general public open API. We'll have a look at something in a minute which has got no security, but more often than not, you have to arrange some sort of secure access to the API. Parameters, these are what we can send in our request from our client to the server to filter and sort the data that we want. So we can ask for a certain period of time in some data or a certain range of something, and we can send that over. That's called a parameter. We'll have a look at that a little bit more. You're probably familiar with what it means even when you see what I'm talking about, but even if the terminology is a little bit unfamiliar, but that's a native rule that we can exploit. The rate limits are set in the API rules again about how many requests can be received over time. So you will be restricted if you try and abuse the limits that are set by the API. This is to obviously look at self-preservation and there's costs incurred in running these things. So if they can minimize that and make it sensible and keep the load reasonable, then that's where those rate limits come in. Pagination is a similar thing. It's about how much data is sent back with each request and response. So if you ask for all the orders from Amazon, you're going to get quite a lot of data come back. So they will intrinsically limit what you can get, and it's called pagination because you get one page worth of information back, and then you can request the next page and the next page, and so on if you so wished. The last rule we'll look at is versioning. So this is to do with revising the API, but making sure that people who are using it are aware and they can continue using the existing API, and a new one can be migrated to if they wish, but you'll do it without causing them any vulnerabilities. So what I'm going to do now is just cycle back through all these rules, and we'll drill down into what they are and what they mean a little bit more. So if we start with resources, this is what a typical request will look like when we're looking for a resource. So the URL there is called the endpoint. So that should look quite familiar to you. And then that last bit there, the /orders, is the resource. We're looking at a particular item on the data that's available to us for orders. That can be anything. That is one of the decisions that are made when the API is being built, what goes there. And it can be nested resources. So you can have orders / a region or something like that. It all depends on the type of data that is being presented. So when someone's talking about a resource and you see this in your request, that's what we're talking about there. That last end after the / is the information, the data, the videos, the user data that we're talking about for a resource. So the security stuff is there's sort of three common areas. I think there's more than what I'm going to show you here, but these are the things that you're going to come across. The basic authentication seems to be a little bit old hat. I don't tend to come across it at all, and it's basically an amalgamation of a username and a password that is encrypted, so it can be passed over the internet, but when it's decrypted, it's you're a known user for that API. It seems to be, like I said, a little bit old hat, but that's the way that functions. If you see a basic authentication requirement for when you're looking at APIs, then that's what we're talking about there. An API key might be something you're familiar with. It's a unique value that will be given to you, and then that allows you to use that to authorize yourself to connect to the API, or you can use it in an application to use that application to connect to the API. But you'll be given that key, and it is unique to you. It's essentially your password. So if you share it, other people can use it, and then because it's given to you, it'll be identified as you being the person responsible for it. The way that it's used is pretty common, so and it makes things fairly straightforward and easy. So I think you'll probably find that more often than not, that API keys are where your security experience will be based. You might have also seen these two, OAuth 1 and OAuth 2. These are popular as well, but they seem to take a lot of the process behind the scenes. So it automates the request and issuing of access tokens, and you can. This is what's used when we're talking about single sign-ons. So you're using Facebook or Google to sign on to certain services. This stuff happens behind the scenes. The main difference between OAuth 1 and OAuth 2 is that the tokens can expire with OAuth 2. So it's extremely secure in that you can only have access for a limited amount of time, and then you have to go through the process again. It's a belt and braces measure to sort of keep everything secure. The parameters are what we're talking about in terms of filtering data. You see the endpoint we were looking at just now with the orders. There's our resource, and then if you see a question mark, this is where we're talking about parameters are being applied to the request. The parameters are defined when the API is built. It's part of the rules, obviously, and you will need to know what you can ask for in terms of the parameters. So in this instance, we've got the option to look for orders that are placed after a certain date, so June 2021. So this is basically a small formula that's allows you to have a variable number there for the date, and you can use this to poll for certain data that suits your needs, and it obviously just makes sorting the data a whole lot better, rather than you having to receive stuff and then sort it. This gets delivered to you already sorted and prepared for consumption later on in whatever you're going to do. The next item of rate limits is the limiting the number of requests that you can send from your client in a certain period of time. It is for self-preservation. It stops the abuse, it controls cost, and it also prevents the overload of the server. So you can imagine, when you get these DDoS attacks, this is a part of trying to prevent that, where the thousands or hundreds of thousands of requests are coming in at one point. There'll be restrictions in place just to stop that sort of stuff going on. And pagination is a similar sort of method of self-preservation. It limits the amount of data that gets sent back. So it's defined within the API rules. You can ask for some information, but you'll only be given a certain amount back at once. So if you want to get a lot of information, you're going to have to work your socks off to make it work for you, just to avoid the abuse. I'm sure there's ways to get around it. If you're a big client and you're going to be paying a lot of money to use these APIs, you can probably circumvent these. But for sort of people like us who are tinkering around the fringes, it's we're going to be sort of restricted to this. But they're usually quite generous, and they're put there to stop abuse, and that's not our interest. So again, stops abuse, controls the cost, and prevents an overload of the server. The last item we'll have a look at here is the versioning. So if you have an API that's in place, people will build their software to request information from that API, and then at some point you, for whatever reason, you want to revise it, you would need to leave that API in place and then have a new version. So when you see like a V1 or something along those lines, that's what we're talking about. There might be multiple versions of an API and they all offer different things, but the sort of standard practice is to leave the version 1 in place, for example, for people to have time to then migrate to the version 2. But that is just an important point. When we look at the documentation in a minute, you'll see that this is a sort of a common thing to find. So it's something well worth bearing in mind. So yeah, just so superseded APIs remain active, so existing users do not encounter problems. So yeah, there's obviously quite a lot of rules to sort of to bear in mind and take on board. I don't think you need to be worrying too much. It's just great to understand what's happening when you see this stuff and you're building. You've got a good idea of what it means. So where do you find these rules? You might have already heard of these things. API documentations. Every API that gets built has it should have a document that is explicit about how you go about accessing it. It tells you all these rules. So when you're building, you've got that in mind, and you build a service that is is going to work to sort of get the right information out, and you're going to send it the right information, and everybody's going to sort of work in harmony, and it's going to be great. But so yeah, whenever you're looking for how things should be working, or if you're doing the right thing, the API documentation should be very accessible, and not saying it's easy to navigate, because sometimes they're quite baffling, but yeah, they're very very prominent in the when you're using APIs. Let's move on to how an API works. You might imagine, yes, it's just more rules. So we use the hypertext transfer protocol, which is you see that at the start of every URL, or HTTPS. The S means it's got a certificate of the security certificate on it to mean it's encrypted, so you can have secure communication there. But it's still called a HTTP protocol, and protocol is just another word for rules. So the parts of the request, which is the information that is sent by the client, that's always the request. You've got 4 parts. You've got the URL or URI, that's used interchangeably, but that's essential. So we know where we're directing our request to, and then we have various methods depending on what our intention is. The get item is to get information. The post is to write some information to a database. The put is to replace some information, or the delete is to delete. So in our request, we define what our intentions are to give to the server, so it can handle what we're talking about. There are other ones there, but these are the main ones. So this allows you to get going with a CRUD application. The create, read, update, delete method that is quite prominent. Within the request, we have a section called headers, and this is sort of meta information, where we'll tell the server what type of data we're sending, and we'll also pass that security data, that authorization data, in the headers section of it. There's lots of other stuff you can pass in there, but that's all we really need to concern ourselves with. And then there is the body part, which is where we're putting our data payload. That word JSON there, you'll see that quite a lot. It's called JavaScript object notation. It's just a method of formatting data for transmission, and it's quite popular. So yeah, if you're going to get into some APIs, then be prepared to sort of learn a bit more about how JSON is structured. I'll give you an example in a minute, but it's yeah, it's very popular. Even though it says JavaScript object notation, it is used with other languages, but yeah, just you don't need to worry about that too much. So that's the parts of a request. Parts of a response. So this is what the server is sending us back. You might be familiar with some of these items. The status code is a number that indicates what's happened. So we're looking for 200. That's the code that means a success. 404, you might be familiar with that one, where you'll try and attempt to request some information, but it's not available. So the 404 code is not found. 503, I think, is server error, but generally, you'll be provided with a bit of feedback in terms of a status code about what's happened. So if you've got some problems, that's a good point to start with looking at. Like in the request, we get some headers back, and it's a similar sort of thing with some JSON formatted metadata about the type of information that it's sending back. So we're telling it we've sent some JSON, it's telling us it's sent some JSON. And again, it's sort of, just formal rules about what's happening, so you can understand yourself when you might have a problem. And again, bear in mind, we could be doing this, lots and lots and lots of times. So it's ideal to have this information should something come awry. And the other part is the body, of course, where that's the information that has been sent back to us by the server. So we just touch on what is JSON, JSON. That's how I say it. So JavaScript object notation is what it means. It's the widely adopted format for moving data about, and it uses a key value method of identifying information. So here we've got an example of it. This is a bit more complex because it just demonstrates how you can nest this information. So in this information, we've got the open and close brackets start and finish the actual object. In the first item there, we've got a key of user, and then we've got a value of another object, which starts and finishes. And then within that object, we've got a key of ID, and then a value of 1, 2, 3, 4, 5, and then another key of email, and then a value of someone's email, and so on. So this is the broad structure of how the data is pulled from the database, and it's organized this way, sent over the internet, and then we receive it that way, and then we can interpret it and do something with it by targeting the items within the data. The tools that we use handle this for us, and so it does you good to know what's happening behind the scenes. But unless you're going to get into some scripting, which some of you might, then you don't really need to know the nuts and bolts of it. But that's what it looks like, and that's what we're dealing with. So we just move on to a typical request response cycle. So this is how the API is working when we're pushing our button. We'll have and so that white line going horizontally is time. So the client will send a request, and the server will receive that request. This is happening in certain instances of the chain near the speed of light. Electricity is instantaneous. Obviously, it's the machinery that slows things down and stuff like that, but it's tremendously fast. So this is happening, and it looks a bit drawn out here, but it's just proportional for our representation purposes here. So the server's received the request, it does a bit of evaluation, sends it back, and then we receive the response, and that's fine and dandy. Now, if we have an item on the database that is in flux, so we're making a pizza or something, and we want to know that pizza is it's got the status of the order is being prepared, it's being cooked, or it's being dispatched, or whatever, we need to send a request again to find that information and find the status of whether the pizza is cooked and being delivered. But if you don't know when that's going to happen, so to sort of keep going back and keep going back, this is we have to keep polling. That's what it's called. We keep going and cycling the request response for this item until we get the item that we want, which is a status code or whatever we say of cooked or ready or dispatched, and then we've got our answer that we want. But the problem with this is we have lots of requests over a period of time. because we don't know when it's going to happen. So we just keep polling and polling. So we got the information. So you will get the most up-to-date information, but it's inefficient and it's expensive because you've got lots of wasted requests and response with all the same information. Now, there's a way to move past that where we have the similar sort of situation. We'll have a request sent and then the server received the request. Then we intentionally build in a delay. So that means we're not sending lots and lots of cycles. So we delay the time between the server receiving the request, doing its evaluation, and then sending a response. So we hope that sometime between it receiving it and evaluating it, someone might have updated the pizza delivery status that it's been cooked or it's being dispatched, and then we can send our response and we receive it, and that's fine. That's all well and good, but it's called long polling. But what happens is that because we take a lot of time between the receiving and the sending of the response, we're not very up together with what's the latest status. You know, we have fewer requests over time, so we don't really know instantly where we're at. So, you know, it's not the best use of the information. And also, like I said before, it's a stateless thing. So if you have a loss of communication, you might end up with having no response at all. So it's sort of flawed, but I think that has been used in the past. The more modern way of doing it now is what we're going to demonstrate here, where the client will send a request, and that includes a URL, a webhook URL. I don't know if any of you are familiar with webhooks, but this is where they fit into your build process. The client will send the webhook, and then the server receives it. Now, whatever period of time between the receipt and the evaluation, it doesn't matter, because the webhook is triggered when someone updates the value that you're talking about on the server. So it's the most up-to-date information, because part of the process is I'll go and click the pizza's ready, and then the webhook gets sent, and then we receive our response. So this is how we're dealing with getting rid of lots of send and receives that are fruitless, or the one that's too long and we might miss the prompt information. This is how we're handling getting that information in timely fashion and with the most efficient process. So yeah, the webhook is triggered when the server is updated, and away we go. So we don't have any larger requests, and there's no delay in receiving the response. If you don't know what a webhook is, it's a method of triggering the response when something changes on the server. It's widely available for use. We'll have a look at one in Integramat shortly, and it might become a bit clearer if you've got any questions about that. Okay, so we'll have a look at some practical examples. I'm just going to share my browser. Can we see my browser? Is that okay?
Yes. Yeah, perfect.
Great. This is a tool called Hopscotch, which it's a great tool for just trying to understand APIs a bit more and do some testing. If you're of that sort of desire, then it's very straightforward and simple. It's a lovely UI, and it gives you all the information that you need to sort of understand how APIs work a bit more. We'll use it with this API here. This is one I like to use because it's really straightforward and simple. I don't know if any of you are familiar with the Brewdog Brewery. This is their API, and it's open to anyone to use it. This is their documentation. So when we were talking about the rules that the API is giving us, here we are. There's the endpoint. There's the authentication. In this situation, we don't have to have any authentication. They're explicitly telling us about the rate limits, the parameters, which we'll look at now, pagination. So these are the information that we were talking about for the rules, and it's there for our consumption here. So let's do a request to the Punk API for our experiment. I'm going to copy this endpoint here. So I'm just using Command C, and then I'm going to paste it in here. The method, we can choose what we were talking about before, whether we want to get information or put information or delete information. In this instance, we want to get. So now I want to look at the parameters. So this is what we're talking about before with the stuff we can get information from. I first need to put the word beers in, actually, there. That's the resource that we're looking at, the beers. And then we'll pick this first parameter, ABVGT returns all beers with a alcoholic volume greater than a certain number. So I'm going to copy that and put that over here. And I'm going to put a question mark after beers. And then I'm going to put that, and then I'm going to put equals 4. Now you can see that Hopscotch has already given us, populated a list of parameters here. So we could have put it into this section here. We could put our headers and information there. We don't need it in this instance. I'm just going to push send, and we'll see down the bottom here is our response, and our response contains all the beers that are the ABV of greater than 4. We can see that one's got a 4.5. But here is the JSON. You can see the brackets there, opening and closing, and the nested situation with all the different data. So I highly recommend just go and have a poke around on Hopscotch, get that Punk API documentation up, play around and see what you think. See what you think about it. And yeah, it's just a great little tool. There's no bells and whistles. If you are getting into a bit of script, you can actually pull out the code here for the different types of stuff. I would use this JavaScript fetch, and you can just copy and paste this into whatever you're doing, and it's done it all for you. So it's a great little tool. I've got a few other examples. Here I've got a table of users. This is in Airtable, and I'm populating that with just some random information I've got from a service called randomuser.me. So if you're interested in using some dummy data, you can go to that website. I'll put the link at the end of the video. So to demonstrate the use of the Airtable API, I've set up a little card website here, CARRD, and I'm going to have a form in there. So if you want to do this yourself, it's very straightforward. Set the type to custom. They've got the inbuilt feature of using the Airtable API connection there. You're doing this, you need to have the API key. So let's go and find that. I'm back in Airtable here. You can find your information under the help section, and then the API documentation. We'll click that and get that open up. Now, Airtable do a spectacular job of preparing an API documentation for the API. This document is specific to my table. So this documentation is generated dynamically, and the examples of script they give are specific to my table. So if you do it on your table, you'll get information for your particular table. So it's a great way of understanding a good documentation. The API key, you can find that if you go into your account details, but I find it easy to come here. If you click that tick box there, you'll see that the key is displayed here. So we copy and paste that into this section there. The base ID is again found in the documentation here. So that is what we want to paste in there. And then that's pretty much it. So I'm going to launch this website, and by all means, I'll put this in the chat and you can go and fill it in yourself. If you so wish, and we'll fill out. So we'll just make sure that I've got 10 records on the table. So I'm going to fill this out. Mail, Mr. That's me. I'll push submit. And we get, okay, thank you very much. And then boy record is here, and we're getting lots of people populating it as well. See, so that's happening through the thank you, Pablo. That's happening through the Airtable API, and you can see it's fairly straightforward to set up. We don't need to know about all the nuts and bolts behind the scenes that we've been talking about. It's good to understand what's happening, but that is very easy to set up. We'll have a look at how you can do this with webhooks. So in this situation, I'm going to set send to URL, and I'm going to use my scenario that I've built in Integramat. So this is already off, just for speed, I've done this already. We've got two webhook modules. One's called a custom webhook module, and you basically just set it up and define it. There's nothing other than that. And this is your webhook URL that you get given here. So we need to use that in our card table. And this second one here is just purely for a redirect. After, if I click that, after the webhook has received its data, then we will get sent to our thank you page. And that's, you know, you literally just set a 301 status. That's our status before that we were talking about, the server status. And then we have our URL that it's going to get sent to. And then this is the Airtable API connection that we're using in Integramat. Very easy to set up. Again, we need our API key when you add a new connection here, and then you pick up the base that you're talking about in a particular table, and then you're able to map the information that you get from the webhook to each field. And we do that here as well. These are the form, these are the fields of the form, and we put in the value of the field, so the title and first name. These match what the fields are in here. So card sends the information with those titles. It's received in via the webhook. It's received in the Airtable API and then populated in there. So now I have changed that to a different the URL form. I'm going to save this here, and then I'm going to reload the site again. It shouldn't look any different. I'm going to say I'm a female. This is lecture. I'll submit that again. Thank you. So our redirect has worked on that webhook there, and there I am here. I've come down and I've populated this now. So I've used that two different API connections to get to the same result. So you can see how flexible it is. Now this, I'll take it one step further. This table is generated with a script. So I've built a script here that's activated by this button, and it's got a variable of 3 users, and you can just push the button and the script will connect to the API. We've got 17 values in there. I'm going to have 3 here. I'll push go, and then we can watch this populate here. So this is now going away, and it's looking at the API. This is the code here. It's very straightforward. It's just asking the API to send back 3 results, and we're doing the same thing as we did behind the scenes with card there. We're mapping the data that comes back here to the fields there. So that is what's that? Is that a third or fourth way of using the API, the Airtable API, to populate this data and get ourselves into a situation where we're sending and transmitting and writing data, and build our own tools with this with these different methods. All right. That's where we're at. So yeah, I'd like to say thank you very much for listening. If you've got any questions, I'll be happy to take them. I'm just going to put a list up here of the sites that we've been using there on the practical examples. Yeah, by all means, take some time to copy that down. And if you've got some questions, then yeah, please fire away.
Thanks so much, Mark. Yeah, learned a lot, and yeah, appreciate all those practical examples to kind of bring it to life. That was awesome. Love the slides as well. I want to know where did you do them in? They were very cool.
Apple Keynote, that is.
Oh, nice.
Yeah, yeah, it's
Awesome.
yeah, it's pretty straightforward. Yeah.
Awesome. Shall I? Could you stop sharing your screen and then we can see everyone? Cool. Perfect. Yeah, ask away, guys, if you have any questions.
Yeah, I got one question. Well, first, thanks, Mark. That was an amazing presentation. I think we can all agree on that. I wanted to ask you regarding the webhooks bit. So when you need to decide whether to use the API in a very straightforward way or use it via webhooks, like what are the main considerations that you should keep in mind to like opt for for either way?
Yeah, I think that's quite interesting. I suppose if you're building something and there's a native API that does exactly what you want, then go with that. If you're looking for a bit of a bespoke solution to something, and you're looking to move some data from one place to another, there's no API or it doesn't work with Zapier or Integromat, then a webhook is definitely what you need, because you can poll it with some data, and then and with Integromat you can manipulate that data and transform it to something different and perform calculations or whatever you want, and then pass it on to something else. So it's sort of a universal option. If your initial attempt to natively build stuff with APIs or with Zapier or Integromat or something like that doesn't produce any fruit, then yeah, look towards using a webhook, and that should give you some satisfaction.
Awesome, thanks.
Cool.
Hey, Mark. Sorry, just thanks again for the presentation. Just a follow-up question to what Pablo asked. Would you say that you would recommend a webhook if, for example, we don't necessarily, like you said, want to continue to ping the server, but we only want to be notified of, say, a refresh data when there is new data? Like in that case, would you say like an architecture of, because I think you could do it two different ways, right? Where you could set your API call to like happen every 10 minutes to check whether there is refreshed data, or you could just set up a webhook, in which case you're being passive, but they'll let you know when there's new data. Is that correct? And
yes.
So in that case, you would prefer to opt for a webhook versus an API?
Yeah. I don't know if any of you use Stripe, but you can have a webhook with Stripe, which will notify you when you can set the criteria, but say you receive some money, you'll get a webhook sent to, if you've built a tool, and then it'll collect the information, and then you can have your own spreadsheet collating your payments. So that you're exactly right. Yeah, the webhook allows you to do away with that incremental polling, and you are in the hot seat there because you'll get the data as it happens. And that's exactly how it works. It's a bit of a abstract thing, but I think the best thing to do is to just spend some time trying stuff with webhooks, and it will click with you. Yeah. But you are absolutely on the money there, Joe.
Great, thank you.
So, Gervais, did you have a question?
Yeah, thanks. Mark, I've used Zapier or Zapier, whatever it is, a few times, but not used Integromat really. What's your views on the functionality and advantages of one compared to the other?
Yeah, that's a quite a popular question. I think Zapier is expensive, and it's also a vertical build. So you start at the top, and you sort of increment your build downwards. So it's a linear sort of thing, and in contrast to that, Integromat is a little bit cheaper, but you can have, as you saw on my screen, it's a horizontal build, but you can split that off quite nicely and have different handling of errors and stuff like that. So I prefer to use Integromat because it does seem to be a little bit more flexible and a little bit more, there's the options. There's a broader range of options to do stuff you want. Depending on what you want to do, I think you might come unstuck with data integrity GDPR wise with Integromat. I don't know whether they're certified for all that stuff. So obviously you're in the civil service there. I don't know if you're looking to do some sensitive data stuff there, but well, that's fine. Yeah, I think in the US, Zapier is sort of, they've got that HIPAA compliance and things like that going on if you need it. But yeah, my personal preference, although they're both excellent, and Zapier is the sort of big dominant force, is if you're looking for some extra flexibility and some customization, then Integromat is where it's at.
Awesome. Cool. Have we got any more questions for Mark? Yeah, I've got one, but yeah, I don't know if anyone had any burning ones before I jump.
Yeah, I got one, Mark. Because you specifically brought up the Stripe webhooks, and I was trying to pull in, like, they sometimes nest the data down, and I can get, when I tie into like something like Bubble, I can only get like the first layer. I wasn't able to get like that, some of that nested information down. I tried like auto defining it, manually defining it. Like, I feel like I get stuck, and then I go and try and read the documentation and immediately become lost into what I'm attempting to do. Is that just a failure of, like, hey, when you set up a Bubble API for your own thing, it doesn't work, or is there a trick to getting some of that nested data? Like, should I route it through an Airtable to pull out some of the further down stuff and then send it back?
Yeah, it's something I've struggled with as well, Tony. It's quite complex, but it's worth persevering with. I'd look into dot notation and bracket notation. That's do a Google search for that dot notation and accessing JSON. Those topics, if you do a search for that, they'll give you some steer on how to access the nested data. It's done in a sort of breadcrumb type way. So you'll start off with the top level and then dot the next level, dot the next level. So it's a little bit long-winded, but yeah, that's where you want to be looking for to get up to speed on that. Dot notation, square bracket notation, and JSON access. That should give you some good steer on how you handle the data. Don't go populating it into Airtable to then extract it again. I think that's sort of going around about the houses, and you might end up causing some sort of extra headaches for yourself. So yeah, if you can get a return, then access that return directly, then yeah, by all means. I have struggled with that with the scripting stuff that I've been doing. So completely sympathize with what your experience has been.
Thank you.
Cool. Have we got any others? Yeah, just come off mute if you do.
I just wanted to, if I can just chime in really quickly. It's not a question, but Mark, I've watched so many presentations on so many things, no code, and this was like incredibly clear and simple for someone who's like doesn't know the terminology and stuff. So just really appreciate everything about this presentation. You're great.
Thank you very much. That's very kind of you to say. I'm glad you're able to take something away from it, and I hope that's the same for everybody. It's
yeah, you should run some workshops for people running workshops.
I'll put you on the list.
Yeah, do it.
Thank you very much. That's very kind.
Awesome. I think that's a nice way to end us on. Mark, is there any additional things or words of wisdom that you want to leave folks on before we wrap up?
I just want to say thanks very much, and I appreciate your time. I hope you've learned something. If you want to have any further chats about this stuff, then contact me on Twitter. My handle is @industrialmark. I'll put it in the chat. And yeah, by all means, get in touch there. I always like to have a DM or two, and yeah, let's chat some more. But no, I appreciate that, and good luck with whatever you're building. And yeah, hope to see you, on Twitter.
Awesome. Thanks everyone for coming, and of course, thanks so much, Mark. And see you next week, hopefully. Yeah. Cheers, everyone. Bye.
Thanks very much.
Bye.